We're going to do a quick rundown of the voltage drop, resistance, and amperage measurements you're going to need to do on the light training system here, the Headlight trainer. This is going to be one for an electrical rotation station that you're going to do. This is going to be very similar to the brake light trainer, but different components here. So I'll give you a quick rundown. We've got our battery here, negative and positive. This is pretty old technology here. This was definitely in Mr. Long's time, but not so much any of your time. Headlights turn on by pulling out. We can control the interior light by turning that knob, and we should actually, it is on a resistor in here. It doesn't work very well. So turn that to turn the interior light on, and then to turn the high beams on, this is mounted down on the floor in a car, and we've got our high beams, the high beam indicator. Our high beams are off because our high beam indicator is off. So let's run through these. We've got our license plate light here as well. Okay, so let's run through these measurements we need to do. We'll start by measuring the voltage provided to the circuit. If you'll look at the multimeter, we are in the volts DC selection on the rotary knob, and our red meter lead is in the volts and resistance port, and we are getting 13.81 volts to the board here. Okay, so now measuring at a component, we'll measure at the interior light here. Now we're not going to get anything because why? The light's not on. Exactly. So if we pull that up and if we turn that, light's on. Okay, so now I can do my black lead on the ground, battery ground, as close to the battery as possible, and the red lead there, we've got 11.25 volts getting to the interior bulb. Okay, so that is voltage at a component. That is the electrical pressure available to that light. We'll do a voltage drop next, and the way that we're going to do voltage drop is we have to have the power on again. Okay, so and we'll take our red lead to the power and our black lead to the ground, and we have 11.16 volts being used by the bulb itself. Now if you get the leads backwards, look what happens. Our measurement is basically the exact same, but we have that negative there. Okay, so if you see the negative, we don't have negative pressure. This is not an electrical vacuum here. That is because your leads are backwards. Okay, on these trainers, you're pretty safe to assume, for the most part, the black wire is going to be ground. Okay, so 11.2 volts. So that's voltage drop. And the next measurement is going to be resistance. And to keep it simple, we'll stay here at this bulb, and we will pull both of these wires off. You don't have to pull the screw all the way out. Just because of the design of these wire terminal ends here, you can just loosen them and then pull them out. We've got our leads here, and we need to put this on. Sorry, I'm trying to not move the meter around a bunch. I'm failing at it. Okay. So with those off, what I'm going to do, and for resistance, it doesn't matter which way you do it, and I'll show you that too. But if we just touch both of those, we're at about 16 ohms, 15 ohms, and you'll see if I turn this around, it's not going to be negative because it's just telling us how much resistance there is to pushing current through that component. And I'm not loving, there we go. Okay, so same thing, no negative. There is no negative resistance. So that is our resistance. We'll put these back in here. And again, like always, anytime that you loosen these up and tighten them up, they do not need to be super tight. Just run them down until they just get snug, and you are good. We don't want to break anything here, strip any of the screws out. The last thing we need to do is we need to measure amperage. And to measure amperage, we need to put the red lead in the money port here, the amperage port. we're going to put that down on amperage DC, and then we need to remove a wire. It is not going to matter which wire we do, positive or negative, but it's usually a good practice to do the ground wire, because right now the ground wire could touch almost anything and it wouldn't be a problem. It would be a problem if the circuit was on and it touched the power, but it wouldn't be a problem if it touched anything. Whereas if this one touched any other circuit, we could have a problem. If this touched the trainer, we could potentially have a problem. Now I'm making things up here because this is going to be a non-conductive coating, so it's not actually going to short out on this, but the ground is always going to be a safer wire to be doing this on. And thanks to Ohm's law, we know that the current in this series circuit through this bulb is going to be the same everywhere in the circuit. So it doesn't matter where we measure it on that circuit. If we did it here to here or here to here, going to be the same measurement. Now we can't actually measure it unless we have the circuit on, so we will turn that on, and what I expect is when I touch this post, that light is going to come on, and it does, and we're at 0.2 amps. 0.2 amps, and I know that's a good measurement because if I take the meter off, the light turns off. That means that we are sending all of the current from that circuit through the bulb, through the multimeter, back to the circuit and to ground. And that means that all of that current is being measured in the multimeter and returned back to the trainer. Okay, so that is a good measurement that way. This should be everything that you need. There are going to be a handful of other measurements that you need to make. Similar to each one of these, there's going to be additional amperage measurements, additional resistance measurements, and additional voltage and voltage drop measurements. My one thing here that I would really suggest is make sure that you take apart as little as possible at any given time. Don't go removing a whole bunch of wires. Don't go moving all three of these at any given time, or at the same time, excuse me, because then you can run into some issues of potentially putting them back in the wrong place. So try and keep the number of wires that you remove to as few as possible at any given time. But otherwise, that is our light trainer. Have fun. I almost missed it. So one last thing here that's going to be really important is make sure that if you put the red lead in the money port, in the amp port, and I call it the money port, you all know this, I call it the money port because it costs the program money. Every time that this gets shorted and blows the fuse, we got to pay for it. And the fuses are not super cheap, okay? And also, if you're at home and only had your one multimeter and you're doing measurements and you end up blowing the lead, or blowing the fuse, excuse me, then you're just up a creek. You can't do the measurements you need to do. So if you put this in this port, it is your responsibility to put it back in the volts and ohms port. And the problem being is if you don't, somebody is going to grab this, they're going to go to do a voltage measurement, and they're going to measure it across a load, and they're going to blow the fuse. Okay? If you take this out of the volt and ohm port, it is your responsibility to put it back. Please do that. Thank you. Now, have fun.